Okay, now we're ratcheting it up here. We're getting a little bit harder. Check this out. Simon is getting out of bed. Let us suppose that the time from Simon getting out of bed until his arrival at school is normally distributed with a mean 55, standard deviation of 5 minutes. I'm sure we can connect with this question. Simon's arrival at school is classified as being late if it occurs after 9:10 a.m. That's really late. One day Simon gets out of bed at 8:08 a.m. What's the probability of him arriving late? Now you have to start recognizing this is normal distribution. Is this the standard kind of question, or is it an inverse normal question? All right, so again, if you draw this out, you'll be fine. Okay, so here's our normal distribution coming up. The mean is 55 in this case. Okay, this is the time it takes him from getting out of bed to arrive at school. One day Simon gets out of bed at 8:08 a.m. Okay, what's the probability of him arriving late? So, a bit of calculation here. How long is it going to be before he's late? So if he gets out of bed at 8:08, he's got 62 minutes. He's got an hour and 2 minutes before he's late. So we just want to know, what's the probability of him taking more than 62 minutes from getting out of bed to getting to school? So that is this problem right here. So this is a standard question where I'm giving you the value and you have to find the area under the curve. So this is just a straight norm CDF. Put in 62, you've got the mean, you've got the standard deviation, and the probability you should get is something like 0.0808. Check that out and make sure that you get it. So the question might say, what percentage of the time is he late if he gets out of bed at 8:08 a.m.? So the percentage of the time would be 8.08%, or about 8.1% of the time he would be late. So first question, just your normal one, which is a bad word to use in this case. The first question is a regular one. All right, for a period of time, Simon always gets out of bed at the same time, but finds that he arrives late approximately 85% of the time. What time is he getting out of bed to the nearest minute? Okay, this sounds very much like an inverse normal problem, but you have to decide that yourself. 55, he is late. He is late 85% of the time. So on our normal distribution, here we go. We want to know what is that value of t, so that this up here is 85% of all of the values under the curve. This is an inverse normal problem where I'm asking you to find the value, giving you the area. Once we know what that time is, we'll then be able to work out what time he is getting out of bed. Now looking at the last question here, we can clearly see that he was only late, getting out of bed at 8:08, he was only late 8% of the time. So it must be later than that. He must be getting out of bed later than that. So let's work that out. So again, this is an inverse normal. So you get inverse normal CDF. It is the right tail that we're looking for. P is 0.85. We've got the mean 55. We've got the standard deviation of 5. Put those in on your calculator. T is 49.8 minutes. So I'm going to say around about 50 minutes for argument's sake. Around about 50 minutes. So therefore, we want to know if he's late 85% of the time. Remember, he's late if he's there later than 8:10. So 50 minutes before 9:10 is going to give us 8:20 a.m. and that's the time that he's getting up. Okay, so if he gets up at 8:20 a.m., then that is 50 minutes. He's got 50 minutes before he's late. So if we look at this diagram here, if you take 50 minutes for a t-value of 50, 85% of the time he's going to be late. Now this example here is getting a little bit trickier, just a little bit. The continuous variable x is normally distributed with probably x is less than 55 as 0.7. So they've nicely drawn the diagram here, so that's nice. If it didn't have that diagram, you definitely want to draw it, okay? Because it really gets in your mind and helps you to see whether your answers are correct. So first question here, how many standard deviations from the mean is a score of 55? That's an interesting question. remember the formula that helps work these out. The z-value, which is just the number of standard deviations from the mean, x minus the mean over the standard deviation. All right, I hope that formula makes sense. So we take our x value, we subtract off the mean, tells us how far away we are from the mean, divide by the standard deviation. So therefore this is telling us how many standard deviations above or below the mean that particular x value is. Okay, so how many standard deviations from the mean is a score of 55? Well, what I want to know is, on a standard normal distribution, which has a mean of 0 and a standard deviation of 1, how many standard deviations above the mean will tell us, give us a quartile, the 70th, sorry, not a quartile, a quantile of 0.7, or the 70th percentile. So that we can do on our calculator, because so far here in this question we haven't mentioned the mean or the standard deviation. So what you want to do is look this up. Here's our mean of 0 and our standard deviations of 1, 2, 3, -1, -2, -3. And I want to know, I'm going to put it around about here, that is going to be 0.7. Now I know about this distribution I've just written. Z is normal, mean 0, standard deviation 1. So on our calculator, this is clearly an inverse normal problem. On our calculator, we would do the inverse norm CDF. We're looking at the left tail. We're looking at a probability of 0.7, p equals 0.7, standard deviation 1, mean 0, and press enter. That will give us that z-value right there. And if you do that on your calculator correctly, you should get a z-value of, check it, 0.5244. Okay, check that on your calculator if you got that value, 0.5244. So that tells us how many standard deviations above the mean that score of 55 is in this case here. So I've related it back to the standard normal distribution to enable us to find that. For part B, if the standard deviation of x is 4, find the mean of the distribution, giving your answer correct to 1 decimal place. So x, our random variable here, is normal. The mean we don't know. The standard deviation is 4. So we'd write it something like that. Remember, we always write the variance there. Okay, so let's look at this formula and see what we know. Z equals x minus the mean over the standard deviation. Well, we know the z value, that's the number of standard deviations from the mean. That's what we worked out in part A. We know the x value. The x value is 55. Okay, that's the actual value along the bottom there. We don't know the mean, and we've just been told the standard deviation is 4. So there we go. We just need to solve that equation. 0.5244 times 4 is 50 minus the mean. Add the mean to both sides and subtract off 0.5244 times 4. Grabbing your calculator out, you will get 52.9. 52.9. Let's just see if that makes sense. Yeah, if we look at this diagram here, yeah, that looks fair enough. 52.9. If I got a number bigger than 55, I knew I'd be wrong. So 52.9 sounds pretty good to me. All right, last one for this very, very long video. Pre-packed bags of bananas are marked as contains approximately 2 kilos. Let us suppose that in fact the weight of the contents of such bags are normally distributed with the mean, that, standard deviation, that. What's the probability that the contents of a randomly chosen bag of these bananas is weigh less than 2 kilos? Okay, A, is this inverse or not? Let's check it out. Normal distribution. We've got bananas here, mean 2.015. Okay, and what's the probability that it has a weight less than 2 kilos? Okay, so 2 kilos is here. We want to know that area there. So this is the usual kind of normal distribution question. I'm giving you the value, asking you to find the probability under the curve. So this is just norm CDF on your calculator. You've got the x value, 2, you've got the mean, you've got the standard deviation, easy. the value that your calculator should spit out is 0.0688. Okay. Part B is a little bit more interesting. Part B says 5 such bags are randomly selected. What is the probability that 3 or more will have contents weighing less than 2 kilos? Right. Now, let's think about this. We've got 5 bags. Each bag either contains less than 2 kilos or it doesn't. Each bag is, the weight is independent of the other. We've got a fixed number of bags. We've got 5 bags. And this is sounding very, very much like a binomial distribution. And in fact, it is. If x is the random variable for the number of bags that have contents weighing less than 2 kilos, x is binomial with an n value of 5, so that's the number of trials, and a probability of success 0.0688. Right, and we want the probability that, what is it? Probably 3 or more. X is greater than or equal to 3 in this case here. Or you could say it's the same as saying x is between 3 and 5, because we've only got 5 bags. So it's really only using the formula 3 times, and I could write that out happily, but let's not do that. Let's use our calculators. So this is Binomial Cdf on your calculator, and what are the values we're going to put in? First of all, n is equal to 5, p is equal to 0.0688. The lower number of values that we want is 3, the upper value is 5. We put that on our calculator, and you should get 0.002691, and that is the probability for this one.